I also asked you to work through some of these, but chances are you probably got them all done. You're just not paying attention. Okay. All of these questions from 21 to 26, all of those answers are found on page 27. So if you go with me to 27, all of the answers are starting here. This is the key to it. The problem is they give you the answer. It could be a fraction, could be a decimal. It depends on how you answered. And you might also have to reduce the fraction to figure out whether or not you got it right. My go-to is to just figure out what the decimal is. What is the decimal answer? And then I match it and see if it's the same. Okay? So if you go to page 21, you just say key to pages 21 to 26 is on page 27. And if you go through these ones, which I think are really, a lot of these are good questions that really make you think about what's happening. So how about this? To warm up, I'll do this page, and then I'll give you some class time. I need it to come back, right? I need you to rehash those ideas that we talked about before. Okay, how are things changing now? You gotta now watch out for three things, in my opinion. Because this unit, like when you get tested on this, on the provincial exam, what is this unit called? Like if you combine 3, 4, and 5, it's just probability. Like the province just sees it as this is all probability. So you need to ask yourself, is it asking for how many ways can something be done? Is it asking for probability, or is it asking for odds? That's basically what you need to ask yourself. Is it just a number of ways? That goes back to chapter 4. Is it asking for probability? You need to stack NA over NU. Is it asking for odds? You're comparing A versus not A, right? So they're all different formats. So a credit card company randomly generates temporary 4-digit passcodes. So it's a 4-digit passcode. Suri is expected her credit card to arrive in the mail. Determine the probability, not number of ways, the probability that her passcode will consist of 4 different even digits. It's a lot. What does different mean? What is that telling us? 4 different digits. Is repetition allowed or not allowed? No repeats, right? No repetition. So there's a restriction there. And it has to be even only, right? So that's another thing to watch out for. So no repetition, and they have to be even. Like what's the probability of this happening? Let's do NU first. NU will be 1, 2, 3, 4. All possible passwords. We're talking digits. Digits means 0 to 9. So that would be 10, 10, 10, 10. It's 10 to the power of 4. By the way, that's just 1 followed by how many zeros? 4 zeros. It's all possible codes. NA. By the way, for me, NA is like, in this case, passwords that have different even digits. Like it's a specific circumstance, the restriction that's put on me. Even would be 2, 4, 6, 8. And I guess 0, right? 0, 2, 4, 6, 8 would be even. So how many options do I have if it's even? I've got 5, right? So because of the word even, I'm restricted to 5, and they have to be different, so no repeats. So I have to combine that. How do I show that? It's 5, 4, 3, 2. Or 5, pick 4, if you will. 5, pick 4. And what is that? I don't even have that on my screen right now. So that would be 120. So now I'm ready. I can go probability is 120 over 10,000. The day of the exam, I want you to leave it like that. Okay, I don't want you to reduce. I don't want you to turn it into a decimal. Just leave it like that, because if you do anything past this, you will lose marks. If you make a small mistake, even that will lose you half a mark. It will cost you half a mark. But today we can just cancel this, right? This would be 12 over 1,000. You can reduce it further. Oh, I put my calculator on the docking station there. But they're even, right? If numbers are even, you can divide them both by half until you can't anymore. But it's 12 divided by 1,000. I go math, fraction. So it's 3 over 250, technically. If you turn that into a decimal, you divide that at 0.012. If you want that as a percentage, it's 1.2%. Let's check page 27. I got that for sure, and the decimal matches as well, so we're doing good. Okay, so that's your chance of that happening. Notice that we talked about permutations and combinations. If you use the fundamental counting principle, it is a permutation scenario, especially if there's no repetition allowed. Then it is a permutation. If repetition is allowed, it's just, I would say, just use fundamental counting principle. But in all of these, order matters, right? You putting a 0 up front versus at the back makes a big difference. That literally is the difference between your transaction going through or not going through. Order matters. So I will say order, what? Order matters. So you kind of have to figure that out too. Like, does order matter here, or is it not important? Does it make a difference? Okay, let's do the next one, the cards. So you're playing crazy eights. Players are dealt 8 cards, no surprise, right? From a standard deck of 52 cards. Determine the probability that a hand will consist of 8 hearts. So a couple of things here. It's probability, and the probability is specifically that a hand will consist of 8 hearts. If you're thinking hands of cards, are you thinking permutations or combinations? Does order matter? Does it not matter? A hand of cards, order doesn't matter. It doesn't, okay? Am I scary or something? You're looking at me like, that's okay. I'll work on that. Maybe I need to change I need to like stretch my face a bit. Smile a bit more, right? Order doesn't matter. Does not, not matter. A hand of cards, think of it, right? If you're playing cards, you're playing this game, you're like, I've got the ace here, the ace of hearts. It doesn't matter if it's over here, if it's over there. It just doesn't matter. You have it, right? So a hand of cards, order doesn't matter. So let's see here. You want exactly, let's translate this, exactly 8 hearts. That's what this question is saying. How many ways can you do this to have exactly? So let's do NU first. How would you do your universal? Out of 52, you choose 8, right? 52 choose 8. Let's figure out what that is. 52 alpha, I always forget. Alpha It's a lot of hands, but that's okay. 752538150. So 752 million hands possible with 8 cards at a time. Let's circle order, doesn't matter. We'll circle that in every question. Does it matter? Does it not matter? NA is what? Specific to only hearts. So how would I do that? How many hearts are there? How much? 13 hearts? Do we agree with that? 13 of each. Hearts, diamonds. Yes, so from the 13, we're going to choose 8 because we want all hearts. The next part is kind of pointless. This one is not necessary, but this is the only reason this is not necessary is because all 8 are hearts. If it had not been the case, you would have had to include this part. 39, choose 0, right? Like there are 39 cards that are not hearts, and from those you're not going to choose any because your hand has all 8, right? What do you always want to check? These two numbers should add up to 52, and these two numbers should add up to the group you're making, an 8 in this case, right? But can I give you an example real quick here? Can you just follow me? Try to follow my train of thought. I'm having stress with my pencils today. If this had been like having exactly 7 hearts, 7, you would have had to say, well, 13 choose 7, but you're still missing 1 card. You need 1 more card to have your 8. You would have gone 39 choose 1, right? This would have been 7, this would have been 1. So the only reason this is right now, because 39 choose 0 is what? 1. For some reason, it's 1. Okay? So really, mathematically, it doesn't affect us right now. If you missed this, you would have been fine. Okay? You do not lose marks, none of that. But I'd like you to think of that. That's happening in the background. So 13 choose 8 is 1287 times 1. That's just 1287. And now we are ready to state our probability. The probability is 1287 over 752, 538, 150. I'm just going to leave it like that. This is my final answer. Let's check the key. I wonder if the key, did it reduce it? Question 2. No, they left it exactly like this. So I'll show you. Right, there's that answer. And decimal is possible, but it's really, really small. Your calculator would not show this. It would show 1.71 times 10 to the negative 1, 2, 3, like however many spots there are. Yeah. P parentheses? Like this? Like show this? Oh, like this? No, you can just do that. That's fine. Just a number. Just stack the numbers, circle it, you're fine. Yes, you don't need to have anything in front of it. Just have your final answer. But the province, if you don't show work and it says show work, you're going to lose marks if you just show this number. So just so you know, you're going to lose. You might lose a full mark, actually, if you don't show work. Okay? Is it coming back? I hope. I wonder if we should do this on the side. Allow me to do a B part here. Exactly 7 hearts. Then it would be 13 choose 7 and 39 choose 1, because you have to have 8 cards. I will just leave it at that. That's just how this would have changed if it had said 7, like anything less than your 8, it changes things, okay? All right. One more here, and then I'll hand it off to you for a bit so you can practice. I do want to cover a new topic today, but I will give you some class time to practice. From a committee of 12 people, 2 of these people are randomly chosen to be president and secretary. Determine the probability that Ben and Jen will be chosen. What do you think? Does order matter? President, secretary, specific positions. Order matters. Order matters. Like if it's saying like someone has to be like pictures, right? Pictures, order matters. Like you have to stand here, you have to stand there. Versus, okay, let me ask you this. Does it matter if I pick 2 people, does it matter whether you get president or secretary? Would it matter? Whether you get the first or the second? Would it change things? Yeah. If you're president, somebody else is secretary, or you're the secretary, right? It matters. Like things change. It's a different setup, okay? If it just wanted 2 people to lead the team, any 2 people, it doesn't matter who gets selected first. Both of them will be leading the team. Then order doesn't matter. So order matters. Just so you know, like that, it matters. And so when order matters, I tend to go fundamental counting principle, okay? So NU, there's president and secretary, right? If we don't care who gets the positions, what would we say? 12 times 11. How else can we write this? 12, pick 2. That'd be 132. Any 2 people assigned. I'll circle this here. And I think I need to add something to why did I determine order matters? Specific positions. So I could turn this into a combination by simply omitting those 2 positions, just saying I need 2 people that are going to lead the team, right? NA, I need, who do I want? President, vice president. Who do I want specifically to be here? Ben and Jen, right? So I only have, at the beginning, I have 2 that could fill a president position and 1 that could fill a vice president, therefore, or 2 pick 2, that's just 2. And I will make a note, only Ben and Jen can fill those 2 positions at this point. So you're reducing your options, right? So probability is 2 over 132. That is how you come up with it. Does that match? Let's go check 27. I'm not going to have it on the screen. I have 1 over 66. Is that okay? Turn that into a decimal or reduce it, and you will get 1 over 66. So it's still fine. Like you still get full marks. You don't get any deductions unless the question says state your final answer as a percentage or decimal. You're fine. I'm just going to figure out 2 divided by 132 is 0.0152 or 1.52%. Okay, if you wanted to check it. We're good? Okay, let me throw something else at you. What if I said, what's the probability that Ben and Jen are not president, vice president? They're not. Minus, does minus come into play here? Take away? So wouldn't it just be 100% minus the probability of them being together? See that? So that I'm gonna add that here. Probability of not together and not being chosen would be 1 minus 0.0152, which is 0.9848, or 98.48%. Seriously, why would you squeeze it in the corner, right? Because I didn't think of it. It just came through. I'm gonna box this in though. This is important. And in the world of probabilities, you wanna, whenever it says not, guys, focus on finding it, subtracting it from your universal. That's when you truly get all those scenarios where they're not being chosen. Okay? Don't try to figure out how many ways it cannot happen. That's too hard. Just figure out on how can it happen, take that away from your total. Okay? That's the way to go with the nots. Okay? Okay. I'm gonna pause here for a bit. So you continue your journey 22 all the way to 26. And 26, there's one hidden there on 27 that I will leave that for later. Yeah, I got your email. 27 has a question in there that I haven't covered yet. If you're willing to try that one, it turns the finding the number of ways into a probability. But you may wait for now, okay? Just try to work 22 all the way to the end there.